Hello, and welcome to Ohio DOT's training for its Multimodal Design Guide, or the MDG. This video is the fifth module of a 13-part training series that will span the entirety of the guide. In this video, we'll focus on Chapter 5, Shared Use Paths. This chapter provides guidance for shared use paths used by bicyclists and pedestrians for transportation and recreational purposes. Shared use paths are physically separated from motor vehicle traffic by an open space or barrier and are one of the preferred bikeway types for a majority of people walking and biking due to their separation from motor vehicle traffic. They are unique in that they accommodate both people walking and bicycling within the same facility and are most commonly designed for two-way travel. Because of this, a distinct chapter has been dedicated to shared use paths in the MDG. Chapter 5 covers the design considerations related to shared use paths, including width and clearance, design speed, sight distances, intersection design, and signing and pavement markings. Additionally, this chapter provides information that distinguishes side paths, a shared use path along a roadway, from other shared use paths located within independent alignments, such as through a park or a forest, which is particularly important when planning and designing intersections. As with anything else, it's important to consider the natural behavior and movements of people who will use your facility. People traveling along paths want the ability to have conversations and talk with their companions. Thus, they will want to walk or bicycle side by side, regardless of the width provided, as illustrated in the image on this slide. A path width of 11 feet should generally be used as the minimum starting width for a shared use path to account for this natural user behavior. Path widths less than 11 feet do not provide space for people to travel side by side while also accommodating passing by users traveling in the opposite direction without increasing the potential for conflicts. This is particularly important on shared use paths that operate at both moderate or high volume thresholds. In some cases, the presence of frequent conflicts on narrower width facilities can result in some people avoiding the facility altogether. There are also situations where it may be appropriate to consider path widths wider than the minimum widths in order to accommodate higher volumes, mitigate safety issues, or address discomfort for users. This is discussed later. FHWA provides a spreadsheet called the Shared Use Path Level of Service Calculator, and it can be used to determine the appropriate width of a shared use path based on inputs such as user volumes and modal split. The table on this slide and in the MDG shows minimum shared use path widths to achieve a shared use path level of service of C. LOS of C means that the path will likely have the minimum width necessary to meet current demand with a modest ability to carry some additional future capacity. By comparison, level of service D means that the path will be at its functional capacity limit during peak periods, which will ultimately result in significant service degradation for users due to overcrowding. You may ask the obvious question, how do I determine volumes for a path if it's new construction? Shared use path user volumes can be collected for an existing path, estimated using a similar path, or projected using an assessment of land use and other demand characteristics that are present within the vicinity of the current or proposed path. Designers may also assume the default modal split used in FHWA's spreadsheet, or adjust that split based on the characteristics of other similar paths. In addition, regionally significant paths where faster recreational bicyclists may be expected with some frequency may benefit from wider shared use path widths. In short, the width of a shared use path should be carefully considered to accommodate the peak demand, which will often be on a weekend or during a period that may differ from the nearby roadway peaks. The FHWA Shared Use Path Level of Service Calculator can also help designers to understand potential volume thresholds where passing movements between bicyclists and pedestrians will limit the effectiveness of the shared use path. To improve the comfort and safety of bicyclists and pedestrians, and to improve the efficiency of a shared use path for travel, separation of bicyclists and pedestrians should consider when level of service is projected to be at or below C, pedestrians can reasonably be anticipated to be 30% or more of the volume of trail users, higher volumes of children, seniors, or individuals with disabilities are likely to be present, or where faster bicycle speeds are desired to serve regionally significant bicycle travel. Where it's necessary to separate bicyclists from other users, such as pedestrians, there are 3 strategies you consider. Option 1, as shown on the slide, separates bikeways and walkways with physical separation between each user type. Option 2 depicts a wide path which separates users with a traversable surface, such as different paving materials. And option 3, which depicts a wide path that separates users using pavement markings alone. Similar to the traversable treatments of option 2, the pavement markings will serve as a suggested position for each user on that path, understanding that the entire space is traversable by any of those shared use path users. Moving now from path widths to clearances, a graded shoulder at least 5 feet wide with a maximum cross slope of 6:1 should be provided along each side of a shared use path. Where paths are adjacent to parallel water bodies or along steeper slopes, a wider separation should be considered. Where a 5-foot shoulder is not possible, the Multimodal Design Guide provides recommendations for physical barriers, such as the fence shown on this slide, and describes how those barriers should be designed. It is not desirable to place a pathway in a narrow corridor between 2 fences for long distances, as this can create personal security issues, prevents users who need help from being seen, prevents path users from leaving the path in an emergency, and impedes emergency response. Although this module will not discuss horizontal sightline offsets, Section 5.3.1 is the location in the Multimodal Design Guide where you can find this content. This is the same guidance as previously provided in the older editions of the L&D and as found in the current AASHTO Bike Guide. Next, we'll discuss side paths. A side path is a term used to describe a type of shared use path that is located adjacent to a roadway, as illustrated by the photo on the left, as opposed to a shared use path that is on an independent alignment, such as one along an old railroad bed or along a river, as illustrated by the photo on the right. The primary distinction between a side path and an independent shared use path is often their intersection context. Side path intersections with roadways occur within the functional area of a roadway to roadway intersection. The geometric and operational design of side path intersections closely follows the best practices for separated bike lanes, which is discussed in Chapter 6 of the Multimodal Design Guide. When designing side paths, the designer should use this chapter for all other elements of design, including path width and other supportive design elements discussed in the chapter. This is essential because separated bike lanes are not designed to accommodate pedestrians, whereas a side path must accommodate pedestrians and bicyclists. The Multimodal Design Guide also provides information on when a side path may be the preferred bikeway type when compared to other on-road bike facilities and a sidewalk. A side path may also be used in addition to other on-road bike facilities. So for example, a road with both a bike lane and a side path to accommodate different user types. In other cases, A side path may be specified to accommodate both pedestrians and bicyclists within a smaller footprint than two distinct bicycle and pedestrian facilities. Next, we'll discuss design speed. In most situations, shared use paths should be designed for a speed that is comfortable and appropriate for the design user profile for the specific project area context. There is no single design speed that's recommended for all shared use paths, and design speeds may change along portions of a shared use path as they travel through different contexts. This is especially the case for longer shared use paths that transition between suburban or rural settings and into urban settings, where contextual conditions and user demand expectations are different. As noted in previous modules, although some bicyclists or micromobility users can travel faster than the noted design speeds, designing to accommodate the fastest possible speed is often not appropriate in many contexts. Where speed changes are appropriate, the MDG provides guidance on the signage and geometric conditions to accommodate those transitioning speeds. Sight distance is another important aspect of designing a shared use path. The minimum length of Crest vertical curves has increased based on the new eye height assumptions, which considers a person riding a recumbent bicycle who has a lower eye height than the typical adult bicyclist. The MDG provides these updated values. Eye height is a fundamental design consideration for user visibility and stopping sight distances, which is further discussed in section 3.5.1 of the guide. As you're aware, intersections are where potential conflicts between path users and motor vehicles are most likely to occur. Shared use path intersections can be at mid-block locations or at an existing intersection of two roadways, as is often the case with a side path. The latter scenario follows the design principles for separated bike lanes, which are discussed in Chapter 6. Where a shared use path intersects a roadway or driveway, the crossing design should aim to minimize path user exposure to motorist traffic, minimize the speed differential at points where travel movements intersect, and provide clear messaging regarding right-of-way to all users moving through the intersection, and to provide design features that result in higher compliance where user yielding is expected. To do this, designers should have a firm understanding of the mutual yielding principles discussed in Chapter 3. Unauthorized use of shared use path by motor vehicles does occasionally occur. In general, this is a greater issue on shared use paths that extend through independent right-of-ways that are not visible from adjacent roads and properties. The guide discusses preferred designs to restrict motor vehicle access to shared use paths, as well as what types of designs are dangerous to path users or ineffective in restricting motor vehicles from the path. It's important to note that the routine use of bollards and other similar barriers, such as Z-gates or fences, placed within the shared use path to restrict motor vehicle traffic is generally not recommended. The Multimodal Design Guide also discusses how to reduce shared use path user approach speeds through the design of shifting tapers and lane narrowing. It discusses considerations for ramp designs at crossings to accommodate pedestrians and bicyclists, and also discusses when to widen paths at intersections to increase the crossing capacity and help reduce conflicts at shared use path entrances. The Multimodal Design Guide includes 5 figures that illustrate various examples of mid-block control treatments. These figures show typical pavement markings and signing for the crossings for instances where the shared use path stops or yields, the shared use path stops or yields near a railroad crossing, instances where the road stops, multi-lane road uncontrolled crossings with advanced yield lines, and multi-lane roads with signals. The figures in the multimodal design guide are illustrative and not intended to show all signs and markings that may be necessary or advisable, or to show all the types of design treatments that are possible at all types of intersection locations. Designers must also review sight distance requirements as discussed in Chapter 3 and use Chapters 4 and 6 to determine the appropriate crossing treatments for pedestrians and bicyclists based on the context of the shared use path and the roadway characteristics. The primary guidance source for traffic control signs is the OMUTCD. The information is located in chapters 2B and 9B of that guide. The information presented in section 5.7 of the Multimodal Design Guide is intended to supplement the MUTCD guidance and is specific to shared use paths. One question we get asked with some regularity is about advance warning signs for shared use paths. In general, these signs should be placed to allow adequate perception response time, ensuring that the fastest path user can see the sign and respond accordingly. Finally, there were some topics we're not discussing in detail in this training module, but which are covered in the MDG. First and foremost, the guide reinforces that shared use paths are used by pedestrians and must meet the accessibility requirements for pedestrians. A list of requirements based on path type is provided in the guide. Additional guidance on the types of users, path design speeds, and considerations at bridges and underpasses are also discussed in this chapter. Thank you for watching this video covering Chapter 5 of the Multimodal Design Guide. For other chapters, please see the additional videos in this series.